Should see my screen. So welcome to the dark web. I always like to start with this slide and just talking a little bit about what exists within this environment and what you can possibly come across. It's made it a little bit difficult when we recruit and we're trying to hire for certain positions from an engineering perspective, because it is one of the only environments and one of the only odd interview processes where I basically have to say, are you comfortable possibly getting exposed to gore porn throughout your just day-to-day role? So content to the dark web can be extremely offensive. I have a tool that allows me to safely search for information within this environment. And then the examples that I'm going to show you where we pivot to live dark web have all been pre-vetted so that there is no exposure for anyone within the crowd. Yeah, and then what our plan is today, we're going to cover the 5 main darknets or 5 major darknets, talk a little bit about how each of them are architected, what selectors or indicators you can see for each one that's on your disk or on your machine if you were to install them, how to access them securely, and which ones are more or less secure, the differences between each of them, and then we'll go into each of them so you can see what they actually look like. So again, I'm Joe DePlato. Great to meet everybody here. My background is cybersecurity. I've been doing it for a long time. I was suspended from middle school back in the 90s for compromising the computer systems back then. That put me on the path of good versus the path of bad, let's say. And traditional CS background. I worked for a military contractor for several years, securing their data centers overseas. I worked for a company called Palantir for several years on their commercial cyber side, where I supported companies like BP, Home Depot, American Express, coming into their security operations centers and helping their teams, teaching their teams how to find evil, deploying Palantir's tools, and then building out additional tools for them that made their jobs easier. Things like, if you're on the cyber side, determine if something is a true or false positive. We were able to take that time, which took analysts 30 to 40 minutes to figure out, and we were able to reduce that to under 5 minutes, which had a huge increase in efficiency for them. I did not set out to be in the dark web or do dark web stuff. We simply saw an opportunity for dark web intelligence and dark web information, took a shot, and turned out that people needed to hear and people needed to know how to browse this environment and how to operate within this environment. I do have my chat up as well, so please feel free to stop me at any point to ask questions. Great. So there's a distinction between the dark web and dark nets, and I want to make sure that everybody's aware of what that distinction is. When I say dark net, I'm talking about the physical infrastructure, whether it's hardware or software, that is needed to access the dark web. The dark web is the content that exists within the dark net. And there's really only 2 true dark nets. We cover those two first. But there is a distinction. Dark net, think of as routers, servers that are running the content, that are helping to route your information. The dark web is the actual content that exists within this environment. I'm going to keep this high level, and I'm not going to use the iceberg model that a lot of people have seen. But I do want to cover some technical terms. I got this slide and 2 more on technical terms just to make sure that we're on the same page. I don't know everybody's technical background. I want to make sure that when I'm communicating, you all understand what those definitions and what those words are. So what is the dark web? There's 3 different areas of the internet. We'll call them the surface web, which is basically anything that you can access with your browser. So Chrome, Firefox, Brave. You open up your browser, you go to Google, that is surface web. You go to any of the news sites like CNN or Fox, that is surface web. We classify deep web as anything that you cannot directly access without some type of action that you need to take or the user needs to take, like paying to gain access or signing in to gain access. I always like to use Netflix as an example, right? Netflix has a surface web presence, but to access the petabytes of streaming content, you need to have a login for that. So we classify that as deep web. So you can see that when we get into the deep web and we get into a little bit deeper on the deep web, there's certain forums, there's certain chans that exist that are on the open internet, but you need a username and password or some other type of access to get into. The dark web is the place on the internet that you require a specific type of software to enter, whether it's the Tor browser, whether it's the I2p router, whether it's the ZeroNet client. You need to take something, download it to your machine. You can't access it directly from your computer without having this software installed, or if you're highly technical, you need to configure your software in a way that can leverage someone else's entry point into the dark web. But either way, you have to take some action to gain access to these areas. So technical terminology, DNS. What is DNS? It's domain name system. It is used to translate human readable addresses into what the computer can read. So for example, I want to go to google.com. I open up Brave, I type in google.com, I hit enter. What actually happens here is a domain name system server takes google.com and it converts it to an IP address so it can know how to route that across the internet to the appropriate location and then receive the response back so that Google can then display information on my computer. I'm sure everyone's familiar with IP addresses. Internet would be incredibly difficult to use if instead of typing google.com, I had to always remember what the IP address of a specific server was. And then now that we have dynamic IPs and stuff's changing, it would be nearly impossible to maintain. Internet, simply a collection of computer-connected systems across the globe. I like to think of the internet as client-server traditional communication, where you have clients and then you have servers and they're communicating broadly back and forth. And then peer-to-peer is direct communication. So Haral introduced me. What we would do if we were in a peer-to-peer network, instead of going out to some central server like Google servers, Haral and I would be communicating, or our systems would be communicating directly with each other and sharing resources with each other. I promise this is my last slide on technical terminology. So TCP stands for Transmission Control Protocol. It is a connection-oriented protocol that allows for error checking and ensures that information is received. It differs from UDP, which is a connectionless protocol that simply assumes the user receives the information. So for example, I always like to use this as an example. If me and Haral are communicating and we're communicating via TCP, I would communicate out to Haral saying, hey, I have a message for you. Haral would say, all right, I'm ready to receive that message. I would send the message. I would say the message has been sent, or I would say message has been received, and we would be good to go. So there's back and forth communication to ensure that messages are received, they're received in the right order, and then we are on the same page. UDP is, I would simply shout at Haral and assume that what I was shouting was received, he heard it, and could move on. And the final thing to understand with the darknet is something called asymmetric cryptography, or public-private key crypto. I'm not going to get into the weeds of asymmetric crypto. Best way I've been able to talk about it and have people understand it is think about this in the physical world. Let's say that I have a 3D printer that can print unlimited suitcases, and I have the only key that exists to unlock those suitcases. We'll call that my private key. And then we'll call the suitcases my public key. If Haral wants to communicate with me securely, he would simply take one of my suitcases, or I would give him one of my suitcases. He would put his write some note to me, put a message in there, whatever it needs to be, close the suitcase, and then ship it back to me via FedEx or UPS. The only person that has access to the information inside that suitcase now is me. Once Url closes it or signs it with encrypts it with my public key, that locks it, and only I can access it and read it with my private key. So that ensures that messages in transit are encrypted and third parties cannot read or see what exists within those messages. Now, if they have access to my private key, yes, obviously they'd be able to open them up and gain access to that. But that's how asymmetric crypto works. I'm able to send out my public key, and with my private key, I can ensure that only I can read those messages. Great. So the first network that we're going to cover is the most popular dark web and darknet. It's called Tor, and it stands for the Onion Router. It is the gateway for the most amount of people into the dark web and the dark nets. Most people, though, do end here. They don't make it further into the other areas of the internet. We've also seen different populations move and leverage different dark nets in other fashions. For example, Tor is blocked in China. You could baseline the traffic at the network layer, and you can get a list of both public, you can get a list of the public IP addresses of what's called Tor nodes, or the entry points into the Tor network. So the government can see not what you're doing, but that you're accessing Tor. So it is blocked by the Great Firewall. We've seen a lot of users in Asia use different darknets other than Tor to still get information out. So what is Tor? It's an encrypted network that leverages volunteer nodes hosted around the globe. And what these nodes do, or servers, is they're used to anonymize the internet traffic so that you can browse the internet and Tor in a very privacy-focused way. So for example, when I connect to Google, my ISP, it's currently Comcast, they can see that I connected to Google. If I search something and I'm not using DuckDuckGo, they'll be able to see potentially what I'm searching, or at some type of ad tech or Google will be able to see what I'm searching. And then all of a sudden, I'm sure everyone's seen this, you start getting targeted ads on your phone when you're browsing other sites with something that you had searched earlier. What Tor allows you to do is browse in a private fashion. So I can still browse the open internet, but Comcast cannot see what I'm doing. Google cannot attribute my searches or my IP directly back to me, because I'm encrypting that message. I'm encrypting information, and I'm sending it out across the Tor network and then out to the open internet. And then finally, Tor was funded primarily by the U.S. government. I don't believe it is anymore. I would have to double check on that, but I'm pretty sure the funding stopped a year or two ago from the government. But it was created by and funded primarily by the U.S. government. So some terminology with how Tor works. There's 3 distinct pieces of Tor. The client, which is you, the user, and the either Tor browser or whatever browser you want to use to connect into a Tor relay. The Tor relay, which is a publicly available Tor node that can route traffic on behalf of all the clients. And then another thing that's out there is what's called the Tor bridge, which is still a relay, but it's a relay whose existence is not public. So I can go to the torproject.org right now. I can pull up a list of all of the publicly known Tor relays and get all their IP addresses, right? So it'd be very easy for me to see if something in my system is connecting or communicating with Tor. I can block Tor at the network level, at the perimeter level, because I have a list of those IP addresses. A Tor bridge is simply a relay whose IP address is not made public. So it allows someone in a country like Iran, for example, who has an authoritarian regimen to still access Tor via a specific bridge that they've been handed an IP address from on a piece of paper or messaged through a secure messaging app. So they'd be able to configure their client to still access Tor, even though the public relays are all blocked. So how does Tor work? Let me pull up my laser pointer and make sure you guys can see this. Sweet. All right, so over on the left-hand side, we have our client. Here we have a list of 9 relays. And then over on the right-hand side, we have our end destination. And we'll call this Google. So one of Google's servers. So the first thing that my computer does is it's going to query Tor or Tor directory server, it's part of Tor, and pull back a list of IP addresses of relays as well as their public keys. It will always use 3 relays. They found that using 3 relays allows for both speed and a great amount of privacy and anonymity. So we'll pull back 3 relays and then build what's called a circuit. So once it has a list of those 3 relays, I will say, hey, browser, I want to go to google.com. So my browser will then say, okay, let's use this circuit to send your message to Google. My computer will then encrypt all of the messages with the public key from each of these individual relays, and then send the message to this first relay. When this first relay receives that message, it will see my true IP address, and it will know to send it to the middle relay with the second IP address in that circuit, but it will not see what I'm trying to do with Google. It will not see the final destination, and it will not see the third relay that this is that's in this circuit. So it has its own private key. When I encrypted my message with its public key, I encapsulated the other 3 messages in here with their public keys. So it decrypts its own message. It sees where it's coming from. It knows to send on here, but it cannot see anything else. So it forwards its request onto that middle relay. Again, that middle relay can see the IP address of the relay that it came from, but it cannot see my IP address, cannot see the IP address of the originator. Again, it can see this IP address for the third one where it knows to send it to, but it does not have access to the end destination or the message within that end destination. So what forwards that packet on to that third relay. And again, that third relay uses its private key to decrypt that message. It can see the IP address of that middle relay, doesn't know about this IP, doesn't know about this IP. And now once it decrypts its message, it knows where the final destination is, as well as potentially the message that's in there. So I put this as unencrypted because when you're leveraging Tor, you technically could use what's called an exit relay or the last relay before it gets to the final destination as a man-in-the-middle type attack to decrypt messages and see where things are going. So if I'm signing into my Gmail, for example, I don't really have control over who that exit relay, who's running that exit relay. Could be a nation state, could be a volunteer, who knows? So it's best to be safe and ensure that when you're using Tor, you're using it in a way that's safe, that's secure, so you're not exposing yourself. So try to use anonymous names as much as possible. And then once it receives this message, it sends a message back to here, and then we just go back up the chain, encrypting the same way. So this one's going to have this end machine is going to have the public keys from the other. So you're going to have that same pathway back through. This is why it's called a circuit, but you're not only each relay is only going to be able to see where it's coming from and where it's going to until you get to those 2 endpoints. Something to note with Tor: when you establish a circuit, every connection during the length of your session is going to go through that same circuit. So when I open up my Tor browser, if I leave my Tor browser open for an hour and I go to a couple hidden service sites, so Tor sites, and then I go out to the open internet, and then I log into my Gmail, that's going to all use that same connection and that same pathway. So if you really want to remain anonymous, every time you do something within Tor, you can restart your connection. You can pull up a different, or restart your services to build a new circuit, so that every path through the network takes a different path. But obviously that's a lot slower. That's going to take a little bit more time, but just something to be aware of when leveraging Tor. The top level domain, or TLD, for all Tor is .onion. That's why it's called the Onion router and Onion services within Tor. They recently, as of October of this year, deprecated what was called Tor v2, or version 2, which contained 16 character URLs. They found a vulnerability within those URLs that essentially, with our computing power today, you could guess everything. So you could no longer hide a service. If I spun up a website and I tried to only share that with friends, it'd be very easy for an attacker to get a list of all the hidden services that we're running, or onion services that we're running, and then start scraping and scanning for all of them. The new V3 has come with some improvements across the board. The biggest one, which is they have 56 character strings. So they're, with our computing power today, it's not possible to guess every single combination or scrape every single combination. So they're a lot more secure. You can have more island sites. Tor is very dynamic. What we've seen from our background with operating and scraping this environment, we have new sites constantly going up and coming down, but you have a consistent set of core services or core sites that have remained pretty resilient over the last couple of years. Many of them will run on multiple URLs or multiple servers, known as mirror sites, so that if one of their systems or one of their servers is down, they can still operate. And you can see some statistics on the bottom there. Great. So next portion, I'm going to dive right into Tor. I'm going to do some searches within our platform and then pivot over into Tor so you can see what Tor looks like. So give me 1 second as I share out my other screen. Oh. Okay, share. All right, great. You all should be able to see my screen. Yes, it looks like you can. Right, so I'm going to search for cocaine. People always like to search drugs on the dark web. That's made it rather popular. On that note, as this is loading, there is a professor out of Virginia Tech in Virginia, Dr. Eric Jardine. He did a study and found that Western democracies like the US, like the UK and Europe, tend to use Tor for illicit purposes, you know, buying humans, buying organs, buying drugs and guns, trying to kill people. And he found that more authoritarian countries, those populations tend to use the dark web and Tor to find news sources, to get information into the country, and more importantly, to get information out of the country. So although Tor does have some bad connotations to it because of all the illicit purposes it is used for, there is some good that does come out of Tor. All right, so I just searched for cocaine. Let me try to find some new cocaine website, and we'll go and visit it. Perfect. So buy Colombian cocaine through the CDG cartel. So this is the hidden service. So that is the address of this site. And open up a new tab. When I launch Tor, just so you guys know what I'm doing, I use a in-cloud one-time use virtual machine just to be extra safe, so that if this virtual machine is compromised, it's a dynamic IP up in the cloud somewhere and not directly attributable back to my systems. So this is the Tor browser. I have it installed on a virtual machine. I just type in that address or paste in that address, and this is it. So you can see it's relatively fast. Tor has come a very, very long way since its inception. I can scroll down through. These are professionals. Tor is, and all of the darknets are reputation based. So they want to make sure that they're putting their best foot forward, and that when you're reviewing and receiving stuff, it is up to standards and multiple people's standards. So both drug user and dealer standards, because you can leave a review. You can typically only leave a review if you purchase something, and people don't want bad reviews. So this is their live active sites. They have bulk delivery, and you can see what their products look like. One interesting thing about Tor that we've discovered, a lot of the sites are getting more up to date, but it's very, I'm going to say 10 years or more behind what's currently going on with the internet. And when I say internet, I'm talking about like UX and UI design and your user experience. They're very old school when it comes to design, because of the encryption, because of the speed of the network. They try to keep it as minimal as possible. But you can see here, right, we have a couple selectors. Someone left their email address up there. Granted, it is a Proton Mail. We have a Wicker address, and then we have somebody's Jabber. All right, so that's a drug site. Let's see if I can find a weapon site. It's Tor tip site. I'm not sure if we have any weapon sites in here, but we'll see. I'm not going to visit link directory sites. So a lot of these are link directory sites. And this is what that site looks like without the images. So it basically just has a list of all of the stuff in there. But I did not pre-vet this. So there are a lot of ads within Tor. And I've been burned personally in the past when doing demos and an ad pops up and it's porn. So I don't want to risk visiting that. Yeah, it doesn't look like I can find a weapon site, unfortunately. Try to search for gun. Yeah, same thing. Okay. All right, so how to access Tor securely. There's a couple ways that you can get access to Tor. The first is just downloading it directly at torproject.org. So if you browse to torproject.org, again, you can download the Tor browser right here. Selecting download, they have multiple options. They have a Windows client, they have a client for Mac, they have a client for Linux, and they have a client for Android. They do not have a client for the iPhone. So you iPhone users, I am one of them. They're third-party branded Tor browsers for iPhone, but they are not created by the Tor project. So I personally wouldn't trust them. Everyone kind of has to make their own choice with it. Now, once you download and access it, keep in mind that When you connect to Tor, you are still exposing the IP address that you're coming from on that first connection. So your ISP is going to be aware that you're connected into Tor. They are not going to see what you're doing, but they are going to be aware that you are connecting into Tor. They'll also be able to baseline how often you use Tor, because they can see when you connect to Tor, right? You're only connecting into Tor when you are using Tor. If my Tor browser is still open on my machine, but I'm not actively browsing around, I am not going to be, I'm not going to be generating any traffic for my ISP to see that I'm actually browsing. So they'll be able to see when I use and when I don't use, when I don't use Tor. A lot of people will use VPNs. So they'll still download Tor to their machine, but then leverage a VPN to browse around, or to VPN into their provider and then connect to Tor. With the VPN, again, you have to trust your VPN provider that they are not then selling your data to someone else or have access to that. So William Lewis asked, are timing attacks used to track Tor users? I personally have not used timing attacks to track Tor users, but yes, theoretically, you could use timing attacks to track Tor users, especially if you are going to be running your own nodes because it's a volunteer network, or have access to a lot of network-based data. Last thing I will say about Tor. Tor is the only true what's called out proxy to the internet. All of the other darknets that we're going to cover this afternoon are not designed for out proxying to the open internet. So Tor was purposefully designed to allow you to browse the regular internet, so Google, CNN, etc., without exposing who you are. So being both private and being anonymous. So that's Tor's biggest distinction. That's also why it continues to be the most popular darknet. Great. So next darknet that we're going to cover is I2p. I2p stands for the Invisible Internet Project, so I2p. And we are going to go a little bit more in depth on this one because it's much more complex than Tor. So this is a peer-to-peer communication layer that you can use to run essentially any service, web service, IRC channel, anything that you can run on the open internet, you'll be able to run within I2p. The traffic is encrypted end-to-end, and every node is going to help with the routing of that traffic. It's closed though. So once you are in I2p, once you're connected to I2p, you can only browse other sites within I2p. Unlike Tor, right? Tor, I can go visit, that Colombian cocaine site, and then I can go visit Google, and then I can go visit CNN, and I can go back to another drug site. With I2p, you are going to be limited with just the sites that exist within that environment. So what is I2p? It's written in Java. Its router that you install on your machine is a proxy to the overall network. So you can almost think of this as an anonymous network overlay, which means the more users who are using it, the more traffic will blend in, the more anonymous you're going to be. So unlike Tor, right, where your ISP can see when you're using Tor because you're making those connections to known or unknown entry nodes or guard nodes. With I2p, once you download I2p and install that router, which you are using to proxy into I2p, it is going to start using a percentage of your bandwidth to help maintain the resiliency and the speed of the network. This means that, if you have a 100 meg connection and you're donating 1 meg to I2p, you will have a consistent and a constant 1 meg stream of data coming out of your system, regardless of if you are using I2p or not. So this ensures that your ISP, again, will be able to tell that you're using I2p, but they are not going to be able to see when you're using I2p or even if you're using I2p. You can simply install it, put it on a system in your basement, put it on a laptop in your office or your bedroom, and then it will route and help support the network, even though you don't actively use it. And then when you go to actively use it, there's going to be no change in your network traffic coming out of your house. So there's a couple things or a couple key points to understand with how I2p works. I really like I2p, so I'm a little bit biased. So I have a lot of stuff on I2p. I'm disappointed that it's not as popular as Tor, but you'll kind of see why once we get into there. Get into the nitty gritty of I2p. But it was great architecture, very resilient, and it was built with a lot of that resiliency and privacy in mind. So the first thing is I2p is going to make a very strict separation between the software participated in the network, so the router that you're running, and the anonymous endpoints or servers that are associated with individual applications that you're running on your system. So in an I2p environment, I could have a computer that's running the router and running a web server, or I could have an I2p computer that's running, or I could have a computer that's running just the I2p router, and then I can have other computers that are running different services and different servers, like an IRC channel and a web server, and I can have them connected to and route through or proxy through that one dedicated computer that's running the router. It doesn't matter. Those each individual application is going to be associated with its own destination. So you don't need to, you can distribute them or you can keep them combined within one system. So what is hidden with an I2p is the information that you are doing, if anything. So because that router is continually connected, it's going to be continually pushing out that information, kind of keeping your ISP unaware of what, if anything, you are actually doing. Second critical concept to understand is something called the I2p tunnel. A tunnel is a directed path through an explicitly selected list of I2p routers. They are using layered encryption, so asymmetric crypto, so that each router is only able to decrypt the information that it needs to continue to send that out. That decrypted information is typically going to contain the IP address of the next router, along with some encrypted information to be forwarded. And then each tunnel is going to have a starting point, the first router, known as a gateway, and then an endpoint. The biggest differentiator between Tor and I2p is that Tor builds a circuit with I2p, meaning traffic can flow both ways. With I2p, messages can only be sent in one direction. So to send a message back, another tunnel is going to be required. So there's two types of tunnels that exist. You should see them on your screen. We have what we call outbound tunnels, which send messages away from the creator, and then inbound tunnels, which bring messages to the tunnel creator. And I will walk through this in a couple slides. Last critical piece of info to understand about I2p is something called its network database. And this is a pair of algorithms that are used to share network metadata. And that metadata consists of two things, the router information or router info and lease sets. The router info is going to give routers the data needed for contacting a particular router, like the public keys, transport or IP address. The lease set is going to give routers the information needed for contacting a particular type of server or destination, like a web server or an IRC channel. And that lease set's going to contain a number of leases, with each lease having a specific or a particular tunnel gateway that allows you to reach that destination. So the full information that's contained, you're going to have your inbound gateway for a tunnel that allows you to reach a specific destination, a time when a tunnel expires, and then a pair of public keys so you can encrypt messages to send through the tunnel and then reach the destination. So let me pull up my laser pointer. If you can visualize this, right? So first, Alice is going to reach out to that network database. You're going to pull back and build out a tunnel. So she's going to pull in information. Turns out that John and Peter have randomly been selected. So their public keys are going to be shared out with Alice. And then down here, Alice is going to build that outbound tunnel. So now, the information is going to be encrypted here. Once it receives or is received by John, his machine is going to be able to see, again, that it came from Alice. He's going to know to send the information on to Peter, but only Peter, with his private key, is going to be able to decrypt the information that Alice encrypted with his public key. Okay, so here on the screen, we have Alice on the left and we have Bob on the right. When Alice sends that message to Bob, the first thing she's doing is she's doing a lookup in that network database to find Bob's lease set, giving her his current inbound tunnel gateway, which is here at Chloe's computer. She then picks, or Alice then picks, one of her outbound tunnels and sends the message down it with instructions for the outbound tunnel's endpoint, Peter, to forward the message on to one of Bob's inbound tunnel gateways, in this instance, Chloe. So we saw in that last slide that Alice built out that outbound tunnel with John and Peter's public keys. So again, John can only see the information that Alice sent to him, which is to forward the message on to Peter, and an encrypted message. He cannot see that message. Once it's received by Peter, Peter knows to forward that message on to Chloe, but as well as the encrypted messages that exist within that block. But Peter cannot see what's happening beyond Chloe or what those messages contain. So when that outbound tunnel endpoint receives instructions, it's simply going to forward on the message as requested. Bob's inbound tunnel gateway, so Chloe receives it, and then it is forwarded down through Bob's tunnel until it receives Bob's actual machine and the type of service that he's running, whether that's a web server or IRC. So like I mentioned earlier when we talked about I2p, these are one-way messages. If Alice wants Bob to be able to reply to the message, she is going to need to transmit her own destination explicitly as part of the message itself. So if Alice did not include her inbound or a dedicated inbound gateway to reach back to her, Bob is going to have no way of communicating back to her. So what I2p has done, though, is they've made this relatively easier, built in with the app, so you can communicate, and it will automatically build both outbound, a default list or a default set of outbound and inbound tunnels. And then when you first get into I2p, it is going to automatically use those when you're communicating within the network, so that you are able to get some level of services as well as communicate across I2p to see some sites. The other thing to think about here is if Alice does not include a lease set but has published it out to the general network database, When it's received by Bob, Bob can do a lookup of the network database to see if he can find a publicly known inbound tunnel for Alice. But that does take time, and that would slow down the entire network. So all in, at the end of the day, like we saw when we saw Tor, it used 3 nodes and built a circuit to send messages back and forth, and that was it. With I2p, at a minimum, you are using, to communicate back and forth, you are using 1, 2, 3, 4, and then we have to go back the other way, 5, 6, 7, 8 different nodes just for a single connection. So this is why I2p is more anonymous and more secure, but much, much slower than Tor. The other great thing about I2p, it has what they call a self-organizing network database, so that when you're running that router, each peer is going to be taking on the responsibility of profiling other routers to determine how best to use available resources and where to route around. If you are a network guy, you can almost think of I2p as a packet switch network, while Tor is more of a circuit switch network, right? Within Tor, if one of our nodes went down or relays went down that's in our circuit, we're not going to be able to work. We're going to have to rebuild the circuit. I2p can transparently route around congestion or other network failures and operate multiple redundant pathways, as well as load balance data across other available resources. So it's able to it's able to self-heal and route around all of this, any type of congestion. How I like to think about Tor and I2p is not competitors to each other, but dark nets that complement each other in their focus. So Tor works at offering a high-speed, anonymous internet out proxy to the general internet, and I2p is working towards offering a decentralized, resilient network. So there's a distinction between those two. But again, as you know, with people, anything that's fast and easier and less complex is going to be adopted more quickly. All right, so a couple things about I2p that I wanted to hit on. If anyone here has a forensic background. So yeah, I'm not going to get into the various things. The biggest thing with I2p is the address book. It's similar to your browser history. So one of the components of I2p, which can be extracted from the installer, or you can simply install it and download the address book, is the default address book. Every I2p node is going to come with and provide the same copy of this address book during install, so that it can access just a basic set of minimal and we'll call it trustworthy services. When you run a node, your node isn't expected to expand that minimal set of address books by importing other information from your subscriptions or places that you found, stuff that you've discovered in areas that or people that you are attempting to communicate with. So from a forensic perspective, if I have the default address book from I2p and a threat actor's machine that was using I2p, I can simply do a compare. I can extract both, and then I'll be able to see explicitly what was added by the threat actor that was using that system. So something to keep in mind when leveraging I2p. Great. So next thing I will do is pivot over into I2p, so everyone can get a better idea as to what I2p looks like. So give me 1 second as I switch screens. All right, y'all should be able to see my screen. Yes. Let's try to relaunch that. All right, back into my handy tool. I'll just simply pull up some I2p sites. Sort newest to oldest. All right, let's see if we can visit some of these sites. You see the difference in the naming convention of these sites. So this is what an I2p URL looks like. You're either going to have the what's called a B32, which has more information in it that allows your router to better find stuff. And then they have vanity addresses. If I come across one, I'll show you what it looks like. But those are more complex to find, and you ultimately need some hash to actually grab and gain access to the site. So I'm going to launch Dark Pursuit again. Hopefully I did not get timed out. All right, sweet. Great. So this is I2p. How I got this installed, I simply downloaded the I2p Java first, and then the I2p installer. And then there is a plugin they have for Firefox that kind of pre-configures your browser. So this is actually the Firefox browser that is pre-configured to leverage the I2p router, the proxy that's installed locally on this machine. When you launch, you can see I'm home, so 127.0.0.1, and then I'm running on port 7657. So everyone has access to this when they initially launch and start I2p. This is what I2p looks like initially. So what can we do? I mentioned that address book. So I'm going to select the address book so you can see what that looks like. So this is the address book that automatically comes with your install of I2p. So this is the I2p, we'll call it what I'm going to call a vanity URL, or a more human readable URL. And then this is the actual destination itself. So how the network and system find and figure out where to route and how to get to your destination. So that's the router. This is what I have personally added. So I have added these two sites. I think anything local. Yep, as well as this site. So you saw how fast Tor was and how Tor worked. So let's see what happens when we attempt to use I2p. And if I'm not talking and nothing's loading, I am purposely doing that so you can see the user experience in I2p as it compares to Tor. So when I hit that button and selected to use open up hidden answers, it used one of my pre-built outbound tunnels to send that request out through the I2p network. It already had the inbound tunnel for hidden answers, so my machine knew how to send it to at least that inbound tunnel gateway. I sent with that message. I2p automatically sent an inbound tunnel for me, so that if it's received by the hidden answers server, I should receive a response back, and it will know how to send a message back to me. So we're going to be using several different tunnels. One of my inbounds, one of my outbounds, one of their inbounds, and one of their outbounds. So that's not up. I am about 10% success rate when going through and showcasing I2p with actually getting anything to load in I2p. All right, so let me do that. Let me try cs.I2p. And I'm actually going to pull up an address from see if that works. Yes, let's not. Fuck. Yep. So at least that's not found. It's found these lease sets, but as you can see, it's having difficulty communicating with it. So it could not actually reach the destination. So at least I get some decent messages. When a website's unreachable, saying the website was not reachable, it's offline, there's congestion, or my router's not well integrated with peers, I may want to retry. I'll retry. I think this route has been running for 6 hours. Yeah. So it should be somewhat well integrated, but maybe it needs to run a little bit longer. This one was the website's not reachable because its lease set was not found. So that's a different message, and that's potentially because my router just has it's not published in the network database how to get here, or my router hasn't come across another router that has that metadata that allows me to communicate with it. All right, let me try another site because I want you to see what I2p looks like. I'm just going to randomly click a couple of these that I know have been up in the past. The tin hats. Tin hat's usually a good one. Yes. Perfect. Oops. Okay. So this is the tin hat. One of the probably this site's been around for a very long time within I2p. But this is what I2p looks like. So again, similar-ish to Tor, but the websites tend to be not as up to date, so more out of date than Tor. But you can see that they're actually running a hidden service on Tor. It's a V2 though. Let's see if we can visit that site. Just want to see if we can get there. Yeah, what's interesting here is I2p Planet opened as well. Perfect. So this is I2p Planet, right? This was updated today. Yeah, this was updated today. Was this a torrent? It looks like this is a torrenting site. That's updated. So people are definitely using I2p, right? We have multiple posts today. But this is more similar to the sites that I have seen on I2p. They look very 90s, right? Very 90s-esque. All right, where did my Tor browser go? All right, so this is the Tin Hats site on Tor. I don't think this is going to load. Oh, perfect. All right, so let's compare the two. So you can see they're very similar. And we've seen a lot of users that are leveraging both Tor and I2p. So oftentimes, if you're running on Tor and you want that resiliency, most places will have some form of I2p presence. Over the last couple of years, we've kind of seen that go down just because of the popularity of I2p has not kept up with Tor. But it's always nice to see someone that has a system that's operating on both. I'm almost wondering too if they're leveraging the same web server. So this is the same server, but we can access it two ways, both through Tor and I2p. But this physical or virtual server that's running this might be the same virtual machine or the same physical machine. It's just leveraging those different dark nets to access and get its information out. Great. So that is I2p. When it comes to downloading and installing I2p, Google I2p for you. So get-I2p.net is the place that you can go to download and install I2p. There's a bunch of stuff that you need to do to come with it. It's honestly very sketchy. When the first time I came here, it took me a while to trust that it's going to work. They do have an easy install bundle, or you need to install Java yourself and then figure out how to get this up and going. Yeah, at the end of the day, you understand the risk when you're connecting into I2p. Your ISP is going to be able to see that you are connecting to I2p. They're not going to be able to see what it is exactly that you're doing. When it comes to your tunnels, you're somewhat protected, but at the end of the day, you do need to give up a public key and an IP address when you're running a server, so that the nodes within the system can ultimately connect to your system. So they do have that layered encryption. You know, you have 8 nodes that you're leveraging public keys from versus the 3 that Tor is using, but the risk is less, but there's still risk there. At the end of the day, when you're using I2p, you can only browse around I2p. So Tor out proxy, I2p does not out proxy. You can only browse around within this environment. That concludes the actual dark nets. So the other 3 systems that we are going to cover are not dark nets. They are actually what we call dark web. Give me 1 second so I get my slides back up. They are called peer-to-peer networks. So Tor and I2p are really the only true dark nets. Of all of the peer-to-peer networks that we're going to cover next, Bazaar, Freenet, and ZeroNet, to remain truly anonymous on any of those networks, you need to leverage either Tor or I2p. And because I2p is not an out proxy, really the only option that you have is Tor. Most of these will come with the ability to not install Tor, but at least if you've gone through and installed a Tor router, to leverage Tor to encrypt your traffic, so that when you're browsing around, you can make sure that you are truly anonymous. All right, so what is a peer-to-peer network? I mentioned this earlier. Peer-to-peer, 2 or more computers that are connected and share resources. So I'm not sure how many people are in here, but we could build our own peer-to-peer network and then share videos, files, whatever resources, compute power with each other. Bazaar, Freenet, and ZeroNet are all peer-to-peer networks. First one I'm going to cover is Bazaar. I am keeping Bazaar in here for both historical reasons, and it might come back. It no longer exists as of March, I think March of this year. It was an open source project that was volunteer run and funded, and it simply ran out of funding. I'll get to that towards the end. The purpose, though, of Bazaar was a different way of doing online commerce. Their problem, or Bazaar's issue, was they did not like the central authorities that control buying and selling. So think Amazon, think eBay. They wanted to be a competitor to both of those, so you can connect a buyer and seller. So you don't need that middleman, which means there's no fees. It also means that there's no restrictions in what you can and can't sell. When Bazaar was up and running, we saw a bunch of users diversify into Bazaar from Tor to have their presence both within Tor as well as a dedicated store within I2p. The great thing that we liked about Bazaar is it's open source, right? So you could contribute to the project if you wanted to. They had a very clean, standardized, and robust API an interface that allowed us to very quickly write our own search engines, find different resources, very quickly find things within this environment, which is vastly different from Tor and I2p, which is difficult to scrape and difficult to curate a list of open resources. So OpenBazaar software written in Go, when you install it, it would install both a client and server locally. Even though I say peer-to-peer, your client was a fat client that would leverage your local server to connect into the network, and that local server was the peer-to-peer part of OpenBazaar. No central authority, reputation-based. Use something called Ricardian contracts. Which means that they can legitimately track signed agreements between two parties, and it cannot be forged or changed after the contract has been signed by both parties. So both parties would sign a contract, like a purchase agreement to buy a product, and it was the price couldn't change from either the buyer or the seller's perspective. All right, so OpenBazaar has some really, really cool architecture as well. I'm a little bit disappointed that they're not around, but I'm going to start off, I might be a little bit around the place with OpenBazaar because there's a bunch of different aspects to it. But in the center of the screen, you should see Interplanetary Name System, or IPNS. What that is a system for creating and updating mutable links to IPFS, or Interplanetary File System, content. So backing up a bit, objects in an interplanetary file system, or IPFS, are content addressed, which means that their address changes every time their content does. So what does that mean? Think of a news website like CNN.com. Now imagine if every single time a new article was updated or edited, the URL changed. It was no longer CNN.com. It was CNN date and timestamp of whenever the change was .com, and CNN.com no longer worked. It'd be very, very difficult to continue to find the site and gain access to the site. So IPFS, it's content addressed. It's very useful for a variety of things, but it does make it very, very difficult to get to the latest version of something, especially if you're trying to get to a store, right? So what OpenBazaar did is they created this IPNS system, and what happens is a name in the interplanetary name system is the hash of its public key, and then it's directly associated with a record containing the information about the hash it links to and is signed by the corresponding private key. What this means is new records can be signed and published at any single time. All I need to know is that original address. So Interplanetary Name System is OpenBazaar's version of DNS. It ensures that once a store is created, you get that hash, and then anytime your store is updated, it's just going to have a pointer to your new store, but that original hash as to when it was created. And this allows you to create that single stable address so that everyone can always get the latest version of your website or your store. Yeah, so interplanetary file system, it's a distributed way of sharing metadata across nodes. And I say metadata, so when you're running your own IPFS system, you hold metadata generally for the network, but the content that you run and own is yours alone. Content is not distributed. They did have plans on their roadmap to distribute or to create and update the system to distribute that content, but as of today, with the project being offline, there are no future updates. The unique thing that we discovered when we were scraping OpenBazaar was, and I wish we could show it to you. Do I have a screen of this? Yeah, here's a screen of this. So this is a drugstore. This is Empire Vendor, but they're very it's very Etsy-esque, if you're familiar with Etsy, right? Where you could scroll through, you could see children's books, you could see jewelry, you could see clothing, right? There was a lot of vendors that you would typically find on Etsy that were moving and leveraging OpenBazaar. I don't know if they're the same vendors. I will say similar vendors because I can't confirm if they were the same or not. But it's a very unique, very fast. It was a very beautiful, beautiful interface to use. But what we found when scraping was, I don't know that those vendors realized that when their machine was offline, it couldn't be accessed. So if I download, I'm on a laptop right now. If I download OpenBazaar to my laptop, I'm automatically going to be given a store, right? Doesn't mean I need to put anything in that store. It's just how it identifies me, and I can browse around the networking system. If I turn my computer off or close the lid or it goes into sleep mode, what happens is my store is no longer accessible. So we had to write some of our scraping bots to hit each site once every 24 hours, but go in 4-hour blocks where it would remove a site if it was hit within a 24-hour period. So it only hit it once every 24. We discovered that people were legitimately, their machines would be on, 7:38 in the morning until 4:30 or 5 p.m. in the afternoon, and then varies based on the time zone that you're in. But they were turning off. And these weren't malicious sites like the drug site you see. Those guys figured it out. These were more of the children's book site, the clothing sites, the jewelry sites, which is something interesting that we came across. We don't think those people realized that when you downloaded and installed OpenBazaar, you were actually hosting and running a server as part of that overall peer-to-peer network. Okay, so users hold no data as of today, no updates. We talked about that distributed hash table, so similar to DNS. The big thing here is 2 nodes, once connected, pull data directly from each other. So that means that if you are not using Tor, when you are connecting to another peer within OpenBazaar, you can see network traffic, you can see network logs, you would expose your IP address. OpenBazaar did not originally support any of the darknets. In their 2.0 version, they did have Tor support. They talked about doing I2p, but with it being out, obviously it's never, it doesn't look like it's gonna happen. By default, when you started to use OpenBazaar, it did not use Tor. So it was not anonymizing you by default. You had to take some extra action to use Tor. So you could see how when trying to break into that darknet space and not having a default for anonymity, people might be a little bit scared of leveraging your system. And like we saw with I2p, and like you'll see with the other 2 darknets, there is no out proxying, or what's called connecting to the open internet. When you're leveraging the OpenBazaar client and using OpenBazaar, you can only connect to stuff within OpenBazaar. The other thing I wanted to touch on, specifically with OpenBazaar, that we saw within like the Tor environment, is darknet markets in OpenBazaar are different. In a darknet market, the marketplace operator is going to be taking on the most risk by running that marketplace. The darknet marketplace operator, is the target of law enforcement, means that the users of the platform are taking on less risk because they only need to access the darknet via I2p, via Tor, doesn't matter, and that's it. They're posting something. They're just an anonymous user within that environment. OpenBazaar is different because anyone using OpenBazaar for illicit commerce is going to need to run that software on their own computer or some virtual VPS system that they're renting, and they're going to start carrying more of that risk because it's more easy to expose them. You have to configure more things. You have to make sure that all of your ducks are in a row. But now you're going to be a broader target of law enforcement, right? There is no marketplace law operator within OpenBazaar for law enforcement to target. So they're forced to target the individual operators or individual vendors. But each individual user engaged here, should be aware of that. something that we found interesting. So Open Bazaar is a decentralized platform. So there's no central server or organization that's managing your data on your behalf. Also means that when you use Open Bazaar, all of your data is kept on your machine running your Open Bazaar node. So the metadata is decentralized. The content is not decentralized. If your computer crashes, gone. Yep. And then they were considering doing distributing that data similar to like a Freenet or ZeroNet model, which we'll get into. But with the project being defunct right now, that doesn't look like it's going to happen. So why do I still have Open Bazaar in here? Cool architecture, unique implementation and use of IPFS. More importantly, when it went down in March, we actually saw it pop back up in, I think it was May or June. And we discovered that there were some Chinese users that had actually forked the original Open Bazaar project, updated the code to point to some servers, which we assume that they were running, to get Open Bazaar back up and operational. As of today, it's kind of hit or miss whether it's working or not. My recommendation is to stay away from Open Bazaar for now. It smells like it's going to be a gigantic Chinese honeypot, but we'll kind of see what the future holds. We are keeping an eye on it. If it does come back up, regardless of who is running it, we're going to spin collection back up so people can at least search, browse around, and get a better understanding of both what's in this environment and what looks normal, what looks anonymous. So unfortunately, I don't have Open Bazaar to show you, so we will pivot over into the next darknet. Freenet. So Freenet was designed for avoiding censorship. It allows for peer-to-peer connections, as well as what they call a darknet mode. And their darknet mode does not mean it's using Tor or I2p. It simply means, I think William had posted a question, so I'll pick on him. If William and I wanted to run our own Freenet nodes and share information, we could simply put it in darknet mode. I would give William the IP address and a password. He would give me an IP address and a password. We would connect our two nodes together, and nobody other than William and I would be able to know what is going on, what's being shared, or even that system exists. Distributed data storage that is very, very static, and every single node is going to store content. However, you have no control over what content is stored. Freenet is the most popular used darknet for CSAM material. We worked with a lot of various agencies, and most of them say that typically if they discover during a forensic investigation Freenet, 10 times out of 10, it becomes a CSAM style case. So Freenet is written in a bunch of different languages. All Freenet nodes contribute a part of their hard drive space to store encrypted pieces of files or encrypted files. Those are stored in a data stored directory in the Freenet installation directory. So very, very easy to find. However, it is encrypted. So although you are storing content, you cannot see, nor do you have access to that content. So unlike other peer-to-peer networks, you as a user have little to no control over what is stored on your data store. Instead, files are kept and deleted depending on how popular they are. So this allows Freenet to be censorship resistant, right? There is no delete file operation. Once something's published and it becomes popular and distributed across the network, it is nearly impossible to take that offline. simply because you're attacking, tens or hundreds or thousands of distinct volunteer individual run nodes that are storing that content. Now, I will say it is hard, but it is not impossible to determine what the encrypted files on your local hard drive are. But because, it's difficult to do that, you need to know coding, you need to know a little bit about cryptography. It gives you plausible deniability. All right, so I do have a bunch of text to get through, and then on our next screen, I'm going to walk you through how Freenet works visually. So I tend to be more of a visual learner, so we'll get to that visual piece, but bear with me for this section. Okay, so how Freenet works. Initially, each node, when you spin up a Freenet node, is going to have no information about the performance or the content of any other nodes around it. This means that when you're routing requests, it's going to be essentially random. And we can get into philosophically how random is, but essentially random. But since there's different nodes and they're going to have different randomness, they're going to disagree about where to send a request, giving a specific key for a file. So the data in a newly started Freenet node is going to be distributed somewhat randomly. As more data is inserted into that node, so as it gets requests for stuff and starts storing that information, you're going to start to see nodes clustering around data whose keys, think of them as hashes, are similar because the same routing rules are used for all of them. So as data items and requests from different nodes cross paths, they're going to begin to start sharing clustering information and clustering around that information. This is going to result in a network that's self-organizing into a distributed clustered structure where nodes are going to hold items that are close in that hash or key space. And there's probably multiple clusters throughout the network. So think about, I always like to use, it's going to date me, but the Game of Thrones example. Let's say we had some torrents for seasons 1 through 5 of Game of Thrones, the good seasons. I could have that with William, so William and our little families could have that over here in the US, and someone else in Eastern Europe could also have that same exact stuff. And we could have our own clusters of nodes. Those clusters, because they've never crossed paths, are just going to be islands amongst themselves, shared with other nodes around them, but store and have the same information. So just because the same information exists in Freenet doesn't mean necessarily that's going to be distributed across every single or all nodes. So how Freenet works. Files on the system are going to be referenced and located using hash keys. So in order to search for a file, our user must know its hash key. And Freenet makes it very easy to search within their system. They have the software already written. So when you search a term or search for something, they're going to translate that into a key for you so its system can search. Once it's known, your system is going to send a request out to its own Freenet node, so your local instance of Freenet. And then it is going to get what's called a hops to live value and some randomly generated ID, so it can be recognized and or rejected by nodes that have seen it before. So when a node receives a request, it's going to first check its own data store to see if it contains that relevant file. If it does, great, then it returns that file along with a message identifying it as the source of the data. And that is very, very important because that's how you have both anonymity and you lack the ability to attribute who published something. So let's say William came across some document and I requested that document and William handed that document to me. In my system, that document will have an attribution source of William. So it will assume that William created, generated, and had that document. So that's important to know because it's very difficult to find who ultimately published something simply by trying to trace it through the Freenet network. So if the system doesn't have it, it's going to decrement that hops to live value, and it's going to forward the request to one of its own neighbors in its own routing table, and then so on and so forth until either the data is found or that hops to live value is exceeded. Then a failed message is returned. If a positive response is received from a node, that node is going to send the data to the node it received the request from, cache a copy of that data in its own store, set the attribution to the node it received it from, and then pass it on to the next node. Now, keep in mind, we're storing files, right? And nodes remove unpopular data. So that means that if we get to a point where our hard drive is full or the amount of space that we have given to Freenet hits that maximum, it is going to start simply removing data from our node, and it determines what data to remove by how often it's been accessed and the last time it was accessed. So if I'm deleting data, it's basically going to remove the piece of data that has been accessed the least or accessed the furthest time away. All right, so how does this work? And how are we on time? Pull up my laser pointer. Right, great. So so let's say I want a cat meme picture. We'll keep it G-rated. So I'm going to send a request to my neighbor node, node B. Node B checks its store. It does not have a that picture. So it's going to send a request to its neighbors. First sends to node C. Node C says it doesn't have it. Next, it sends it to node E. Node E doesn't have it. Node E and node C, for that matter, are going to do similar things. They're going to send out to their neighbors and then still decrement that hops to live value. So node E sends to node F. Node F doesn't have it. Node F sends it over to node B. Node B obviously says, no, brother, I don't have it. So node F goes back to node E saying, I don't have it. Finally, node E sends to node D. We found our data. We found that cat meme picture. So node D sends that picture to node E, or node E downloads it from node D. And now node E sets the source of that data as node D. Node E and B communicate, and they do the exact same thing. Node B receives the picture, and node B sets the source as node E. Node B has no visibility into where node E pulled that from, or even that node E got that data from node D and node E didn't have that data itself. And then node B and node A do the same exact thing. So node B sends the file to A. Node A sets the source as node B. And because node A sent that initial request to node B, it simply assumes that node B had the data, and it just took a little while for node B to get that data back to node A. So that's how you have both that plausible deniability and you protect the source of who published some piece of information. Okay, and I believe I'm getting close on time. I got 20 minutes left, so I'm going to speed through Freenet because I want to get to my favorite darknet, which is ZeroNet. So let's see. Nothing too crazy here, more deep end technology stuff. Okay, so Freenet's very different from Tor and I2p, right? Self-organizing distributed file store. In some ways, you can almost think of Freenet as safer than Tor or I2p. For example, Tor is going to use an exit node, and those are points where your packet's finally going to reveal the true destination so that you can view those pages. The exit nodes typically are the target of nation states so that they can, do man-in-the-middle style attacks. With Freenet, because it's peer-to-peer and uses distributed server technology, it's only going to use the hard drives of your trusted network if you're not part of the public Freenet. Therefore, it's going to be completely inaccessible to anyone unknown or outside of that personal network of trust. So this means that Freenet network, it cannot be taken down by shutting down any one specific server or node because they're unaware of who you are or that you're even running Freenet. There's no out proxy in Freenet. So once you're connected to Freenet, you're there. And then it's obviously, you can think of it as decentralized file storage. There is a public Freenet, and I'm going to bring up the public Freenet momentarily here. Okay, so the big thing I wanted to cover here is the data being distributed. So the encrypting of the data within your node is meant to keep Freenet node operators from being able to figure out what type of information is in their nodes. But if they really want to, they can. So there are Python scripts. You can go out there and you can go to Google and Google like Python Freenet decryption. And there's some stuff out there that will allow you to see, if you're running Freenet, what is running on your node. That encryption is there to keep operators from having to know what information is in their nodes if they don't want to and have the technical capability of doing it. The distinction is more a legal one than a technical one. So Freenet's creators think that it's not realistic to expect a node operator to try to continually collect and guess possible key combinations and then check them against the information in their node, even if such attack is viable, so that they assume that a sane society is less likely to hold a node operator liable for such information on their network. I don't know of any legal cases that have used that defense. Wouldn't recommend anyone here be the first one to try that. All right, great. So I'll do a brief demo of what Freenet looks like, and I think we have like 14 minutes left to get through ZeroNet. Just give me 1 second. Share. And I'm on.
Yeah, Joe, just wanted to say that there is a pretty good break after this before the next keynote. So you can take a little bit more time if people are sticking around to go through this.
Perfect. Thank you, Url. Okay, so everybody should see my screen. On your screen is Freenet. So when you download and install Freenet, right, it's going to run on your local host as a server on 8888, and by default, it is going to use, I think this is Chrome. What browser am I using? Don't have about in the browser anymore. I think this is Chrome. Can't remember what browser I'm using. But anyways, it's either Chrome or Firefox. It's one of the two. And it will launch in incognito mode within that browser, and then bring you to your local host. So this is Freenet. You can see my current security is set to low. I have no connected friends and 10 strangers that are connected into me that my node is sharing that data. So this is that main page. If I wanted to go to a website, here's an index with different categories. I can click it. What happened is my Freenet node here is reaching out to the network, kind of like I said. It's hitting other nodes. It's saying, hey, do you have this file? This file in this case is a website, and then it's returned that website. So now my node is going to both have and be able to share this information if other people request it. And you can see the last time these sites were updated were March of 2021. It's been a while. We've seen this site up and down. I think this guy only updates the site like once every 6 months or so, because we've seen this site be pretty out of date, but also randomly have like updates. Like I think the last time I checked, he didn't have an update from 2020, and now he has an update as of March of 2021. Unfortunately, I am not going to randomly click on stuff within Freenet simply because it's very, 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 very risky. I would not recommend anybody use Freenet. Even sites like this that say an index without any type of pornographic or shocking sites, it's still a crapshoot because they are not going through and vetting each of these individual sites to confirm like what that site actually is, because there's a lot of stuff that goes on. But again, here's another Freenet site. Looks very this one should be benign. I'm not going to click it. Get rickrolled. So yeah, so you can go through. You can see this. I would not recommend running Freenet. You still, at the end of the day, don't have control over what your system is hosting. So, you can just simply by running Freenet, you have the potential of supporting some abusive material. So it ends up being not worth it. In our scraping, what we've seen is a pretty decent size portion of Freenet is leveraged for malicious type of pornographic material. So it makes it's not worth the risk. All right, ZeroNet. Sorry, I have like 3 different screens, so I have stuff popping up on different screens here. Great. So ZeroNet. ZeroNet is my favorite darknet. Super fast. We're going to get into it in a second. It is a decentralized peer-to-peer dark web, we'll say. It's also the Bitcoin internet. So it uses Bitcoin cryptography. I love crypto. And it uses BitTorrent technology. I love torrents. To build what they state is a decentralized, censorship-resistant network. And it really is. Because similar to Freenet, once you publish something in ZeroNet, it is stored on all of the peers that have come and visited that site. So it is impossible. You can't go against a specific server. It's impossible to take down content once it's been published, unless you go after each individual peer. With that said, it's not anonymous by default, but they do have a plugin with Tor that allows you from both the client and their server or the torrent client to leverage Tor to anonymize your traffic. Why we've seen a lot of uptick in ZeroNet in Asia is because Tor is blocked, torrents are not. So ZeroNet traffic blends in to traditional traffic in Asia because they liked torrent, and they can your traffic's going to blend in when you're torrenting. You're still going to expose that IP address. They might not be able to see exactly what it is that you're uploading or downloading though. All right, so ZeroNet written in Python, it has a web-based console, and that custom file server honestly needs a little bit of work. Once you get a lot of sites on your server, it starts to become a little bit sluggish. Instead of an IP address, you get a Bitcoin address. It's an actual, real, usable Bitcoin address that you can send and receive payments on. ZeroNet then uses the BitTorrent network to find peers that are seeding a site, and will download site content from those peers or publish yours out to the torrent network so that other people can find it. The big thing here is peers. So me as an operator, I have the option to delete something, to not share something, or seed content that I come across. So unlike Freenet, where they just kind of arbitrarily take control of your hard drive space. Within ZeroNet, if I come across a site or some type of content that I just don't want my node to be part of, my torrenting node to be a part of, great. I can just ban that or blacklist that site from ever sharing or leveraging my system to share out its content. So it makes it very easy to police your own your servers. The big thing here is by default, you do seed a site immediately once you visit a site, and then you have to go through and unseed it. And then not anonymous. I think I said that, but I'll say it again. Not anonymous by default. When you're using BitTorrent, right? So you will expose your IP address unless you're using Tor or a VPN. ZeroNet asymmetric crypto, again, uses the same encryption as Bitcoins. You can accept payments. I said that. So during site creation, you, the owner, so you node operator, you're going to create 2 keys, one public, one private. That private key only you have, and it allows them to both sign and update new content for the site, and only you have it. So this means, let's say I'm running a site, let's say I'm running a blog, and I have 100 followers that are also using ZeroNet to access my blog. What happens is I make an update to my blog, and then I sign that with my private key. That gets pushed out to the torrent network. It's confirmed that it was signed with my private key, and then automatically or automagically, all of the torrenting nodes or the peers that are also hosting and publishing it are going to see that update across the torrent network. They're going to then download the information or the new updates from my site and then continue to publish out and propagate that through the torrenting system across ZeroNet. So site updates are handled by the operators. There is something that they have called the content.json file, and that file is updated by the site owner and sent out. Every single node then compares the content.json file to their own, and if it's new, it will then update theirs and then download the new content, then updates other visitors to their node. What's unique about ZeroNet is that it doesn't verify everything in the content.json file. It simply verifies that the content.json file was created and signed by the node operator. So for example, how ZeroNet works, right? I say, hey, I'm trying to get to Joe's site. Please send me some IP addresses for the site. I send that out to the BitTorrent tracker. The BitTorrent tracker then sends back to my client, here's some IP addresses. Great. I then download the content.json file and verify that the file is owned and signed by the address owner. I then open up the file, and that file is going to contain a list of all of the file names and hashes associated with that site. I then reach directly out to those 2 nodes, and then I say, hey guys, I want to download the rest of the files. I then download the rest of the files, but I don't need to verify each file was signed. I simply ensure that the hash that I'm requesting is the hash that I was downloaded from that signed file. So you can see from a speed perspective, it makes it very quick to download in and get stuff. And then as soon as I grab it, I start seeding it. You can think of ZeroNet as an alternative web distro platform. Any site can be audited. It's 100% transparent, and you can clone sites. You can actually create your own version of that site. But by the act of cloning, that site then becomes yours, and it's going to be different than and away from the original site that you cloned. The great thing about ZeroNet is the sites that you have are going to be available to you even if the site operator is offline and the site is no longer updated, because you have the latest update stored locally on your machine, and you will still be seeding that out. And they have that zero trust model where it's impossible to modify a site without that private key. Users are going to own data once they're on. Here, the closing is 4:35, so we have an extra 15. All right, I will make it. I'll make it fast for all. Thank you for that. Yeah, I should only need another 6 or 7 minutes or so. So Users own the data once it's on their machine. So if any modifications are made, the site gets a new address, and the modifier will be the new original creator of that site, which brings up unique forensic opportunities. We can compare that content.json file because we'll have those hash values, and we can see hashes changed over time. We can see when sites were cloned, what specific pages of a site or an app were changed by the modifier. All right, so ZeroNet. Access ZeroNet. All right, perfect. So, second. Okay, y'all should be able to see my screen. Perfect, I see it. Awesome. So, welcome to ZeroNet. When you download and install ZeroNet, first things it does, again, you're installing a server locally running on 43110, and then this is the default address that comes as a Bitcoin address. That's ZeroNet's Bitcoin address. I've already enabled Tor, so I've by default this is disabled. I have enabled it. I am also using the Tor browser for my browsing for an extra layer of security. Because ZeroNet runs JavaScript, right? It's possible for people to attempt to run malicious scripts, and I don't necessarily want to expose my IP address or other parts of my system, my anonymity or my privacy, which is why I use Tor. The great thing about ZeroNet is this. On the left-hand side, I have connected to 4 different sites already, and you can see when the last time a site was updated. So Xero Sites. Let me refresh this. Dang it. Go back. So Xero Sites was updated 6 hours ago and has currently 298 seaters. Xero Hello hasn't been updated since November of 2020. Xero Name was updated on December 10th of 2021. And then this site's been updated on January 22nd. What I like about ZeroNet is that it's the easiest dark net or dark web to find interesting stuff because they have this thing called Xero Sites, which is their version of monitoring and seeing what services and forums and blogs are out there and then organizing them by content, right? So you could submit a new site here to the ZeroNet proper, and they will put it here, or they will simply find it as people are publishing stuff. And then I can scroll through and I can see, right? So here's some blogs. I can see which blogs are popular and which ones aren't. You can see there's a lot of different Asian sites that are on here. My favorite thing is they explicitly put porn into its own category, and you can remove it or filter out anything like that, which is much nicer than some of the other stuff that you see. And again, you see how much compared to the other dark nets, how much Asian content exists within this environment. So let's say I want to go to let me find something that's not illegal. Let's say I want to go to a site. Dang it. These are always updated and changing. I had some good ones that I'll go to a guide site. Perfect. Looks like this is in not English. So when I click this site, what's going to happen is my client is going to reach out to the BitTorrent network and it's going to say, hey, please send me some IP addresses of who owns this site. It's going to return some IPs. My machine is then going to reach out to those IPs, those peers directly, ask for the specific files that were in that content.json file, or download it first, verify it, and then ask for those files, and then start downloading. Once I do this, my client is also going to start sharing out this site. And it looks like we currently have 12 different seeders. So I'll click it. You can see what happens. Found 11 peers reaching out. That green bar up top that you saw was it downloading, and now that site has been downloaded. I am now seeding this site as well, and we are browsing the local version of this site on my machine. If the content owner were to update the site, my torrent tracker would see that. It would then update the site, and then this would refresh. If I go back to our home page, you can see recently downloaded up here. It will also appear eventually under connected sites. I can see the last time that this site was updated. Great. So I know we went a little bit over. I wanted to thank everybody for their patience. I hope that you all found this somewhat interesting.